Hi and welcome to Make or Repair. It's been a little while since I've done a mailbag video, but I've got a little pile here that has arrived just recently, and one of the reasons I like to do mailbag is because it enables me to talk about some of the things that I've got on the go and that I'm thinking about doing, even if they come to nothing. But here we go. So here's my parcels today. Here's a few also that I'm going to mention, and let's get these done straight away. So the first is this huge packet, and I'm not actually going to open this because it is actually sealed, and it contains a PIC 24J FJ 512 blah blah blah, and it's a 16-bit 512K microchip. Well, there's two of them actually in this huge container. They've actually sent the panel that the factory delivered them onto me, despite the fact that I've only got two. The reason I've got these is because I'm actually switching. I was using Cypress PSOCs up till now, and they have a lot of components on the chip, but they've just become too expensive. So for run of the mill, I've switched to this as my standard, I think. I'm going to do a few tests and build a few bits and pieces up with these, and do a few development boards and things like that to just get the hang of them, because it's been, I don't know, 15 years since I programmed a PIC microcontroller. The other one, which is similar but much more interesting, this is a DS PIC 33CH512. So this is a 512 512 kilobytes of flash RAM on here, and it's a dual core digital signal processing PIC microcontroller. So it's got all the normal PIC microcontroller stuff in, but it's got a lot more registers. It can do, for example, 16-bit, multiply two 16-bit numbers in a single instruction cycle. And it's got two cores, one of which runs about 200 megahertz, and the other one runs about 210 megahertz, I think. So, and they run independently, asynchronously. So this is going to be quite interesting. The reason I got this actually is less of its digital signal processing, but more that it's got a lot of analog to digital converters and digital to analog converters and comparators and things like that on it. So it's a little bit closer in some ways to the PSOC that I'm used to, except it's different architecture, different frequency, different instruction set, and lots of other things. And these are about £4 each, by the way. I've taken the Explorer board, which is quite expensive, and cut it down a little bit and made my own version of it. So I'm just going to solder these on and learn to use these DSPs. Some other bits and pieces. There's some interesting looking resistors just here. And this one is a 1 gig ohm resistor, or 5 1 gig ohm resistors. And then we've got some just 100 megs, and these I think are 5 gig ohm resistors. So these are to calibrate a capacitive leakage meter that I'm working on the design of at the moment. So so there's a calibration tool. So I'm actually going to use some of these for that. I'm going to use a few to calibrate my programmable current source, the low end of that. And also, I'm going to make a few little, plug-in boxes so that I can substitute these into circuits very easily. There's also some transistors here, complementaries, which I'm using for the power supply on that capacitive meter. So it's not just a capacitance meter; it will measure capacitance, but also measure specifically leakage of things like electrolytics, which is why I've got it really. Okay, let's get to the hoard of new stuff that I haven't opened yet. And I think there's going to be a common theme on here, because I'm trying to plug a few of the gaps in my lab. So let's start off with this one, I think. Okay, so from China, well, it says one tester, which actually is probably what it is for a change. Normally they write any old rubbish on there. Slightly dodgy box. A completely user manual and warranty. I doubt really that's going to do much. That's all she wrote. It did have a battery warning on this bag, so So some of you will recognise this adapter as being a fibre optic adapter. I can never remember the letters for them. And so there we have it. So this is a fibre optic light source, and it's supposed to deal with two different wavelengths, so 1310 and 1550 nanometers. It is completely without power at the moment, and despite claiming that it has batteries, it doesn't. So the reason I've got this is because I do actually have some fibre optic light sources, but they're all kind of things like 850 nanometers and things. And I realised I'd kind of got a gap at this end, and I don't particularly need these to be ultra precision instruments. So I don't necessarily need these to be totally wonderful instruments. I just need them to be pretty much in the ballpark. And let's take out my power meter on the other end. However, if I connect up this different cable, it says it's supposed to be better than minus 5 dB, and we're reading minus 3.8 on here at the moment. So yeah, that's kind of much more like it, really. This is a little bit iffy. I've got it kind of just loosely plugged in at the moment, but at least the receptacle is physically the right size. So yeah, so one of the things I need is most definitely some more adapters for these. I'm kind of hoping they'll be in one of the other boxes. Okay, so let's put those to one side and see if one of the other boxes does indeed contain those. No, this is something completely different. This is a small voltmeter, and I bought this because it didn't have any dimensions, but it looked like it might be the right size to replace a meter that I do actually need to replace. And although it will need a new scale printing, at least it might be a good step in the right direction as it happens. I'm not so sure. I think this is about 5mm deeper than I need it to be. I've just been hunting around buying old meters here and there on the hope that I can find one which will actually replace the one that I've made a mess of, basically. Let's keep pressing on. This is in an eBay bag, but I don't think it is actually an eBay product. No, it's taped down, so clearly not. It should be, yes it is. So this is some fibre. So these are ST to ST terminated fibres. So ST is this kind of like little bayonet connector on the end. Let's zoom in a bit. So there you go, little bayonet connector on the end. The cable spec itself is hopefully printed on the cable, but it should be. Unfortunately, I've got a length of cable that doesn't have its spec printed on it. But fortunately, there's a card, and it is, seriously, oh yeah, 62.5/125. So 62.5 is the micrometers of the core, and the 125 is the sheath. Okay, moving on, more Chinese. Okay, not what I expected at all. Yeah, interesting. So these are SAW filters. So you can see this is just an RF device. Signal comes in one side, it goes through a SAW filter and out the other. Now, I've got to be honest, when I looked at these, I thought, oh, that input track and output track are very wide. I wonder if this really behaves like they claim on the diagram. So I'm going to run this on the vector network analyzer and just find out how good or bad it is. If it's good, then what I can do is I can just, these are standard package sizes, so I can just remove the SAW filter in the middle and put whatever frequency filter in that I want. So SAW filter is like a narrow band pass filter. So it's in this guy. And unfortunately none of these contain the things that I'm really waiting for, which are a lot of like end adapters for my optical stuff. But anyway, not to worry, can't be helped. Yeah, so this is quite an interesting little device. Let's take it out of its wrapper. There we go. So I'm going to make a little project out of this, and this is a gas detector. This one is MQ-5, which I can't really remember. It's methane, propane, and a few other gases that this will detect. And one of the reasons I got this is a few months ago I went in our sort of outside workshop, the one we do metalwork and woodwork and stuff, and there was the smell of gas in there. And one of the gas bottles that I use had actually, the seal had failed. And there was quite a strong smell of gas, and I thought it might be quite useful. It's probably been leaking for quite a while. I thought it might be quite useful to have a little sensor near there. And first up, I'm just going to create a very simple analog sensor with a kind of moving coil meter that will just indicate the amount of gas that is present. And then I'll probably extend that, and I'll put a comparator on it so that it can detect a level of gas and kind of flash a light or something. And then what I might do is I might connect a little Wi-Fi board to that and have that notify my phone in the event that it detects something. So perhaps, you know, if it detects something, the Wi-Fi will turn on, connect up and send a message to my phone and then turn off, basically, because it's probably going to be battery powered. Now, one of the things with these is that they do require current. There's the sensor inside it is tin and something. Does have to warm up in order to sense gases. So that means that for at least a little while there's going to be a considerable current draw, and then I don't know what its kind of quiescent current would be after that. So that's one of the things I need to find out to see whether I can make this battery powered or if I'm going to have to make it on a little plug pack. Anyway, it should be fun to do that. It's a nice one of those nice little kind of fairly trivial projects that you can either leave trivial or turn into something more complicated. Okay, I just realised I opened up with the wrong camera active, but anyway, not to worry. We've only got as far as the bubble wrap. So, obviously a piece of test equipment of some variety or something similar. Definitely a large piece of lab equipment anyway. Alright, I think we're there. So I've opened it pointing backwards, and so there you go. This gives us a little thing to worry about. Do not connect. Right, okay, do not use. Pick it up, turn it around and see what it is. So here it is. It's a Photodyne model 1975 XQ optical attenuator. And as I said, just trying to fill a few of the gaps in the workshop. Now these optical inputs are, what are these? These are SMA 9 something or others, I can't really remember the number. They're just literally screw-on connectors. There's a hole and a screw-on connector. And I do have an odd cable that will go in those, but not many. And I'm having some difficulty finding several. And also I'm finding some difficulty finding adapters that adapt this size up to things like this connector just here. So anyway, we shall persevere and see what we can find for these connectors. I can certainly do some stuff, but of course the intention is to repair this and get it up to working order. I notice as well that the switch on the front here is pushed out, but yeah, there we go, that's fixed already. So there's a few dents on the front, but this is just a plastic film with all these touchy-feely, disgusting membrane buttons on the front there. But anyway, fingers crossed. So I should be able to dial in a static amount of optical attenuation on here. And I think there are two primary mechanisms that come in place. One is a very expensive crafted graduated filter that essentially slides across. The other relates to a variable gap. So we have our light coming in on a fibre optic, and theoretically the two pieces of fibre should join together. If we move them apart very, very fractionally, then light spills out down the side there, and actually we attenuate. And if I look at, so if I have a look at this, these are some 3M variable attenuators, and there, oops, yeah, and there they are. So there you go. I can literally extend the gap between the two ends, or bring it down so that there's a fibre fastens on this end on this thread, fibre fastens on this end on this thread, and the two literally can be moved apart and then locked in position with this centre barrel to any attenuation you would actually like. And that's all it's doing, is it's just creating an air gap between the two fibres. Because the fibres themselves, although they look wide, the actual fibre in the middle is really tiny. So even on a small device like this, there's plenty of space. So is this using that method? Well, kind of I hope not in some ways, because although it does attenuate, one of the problems with that is back reflection, because you've got a refractive index between the air and the fibre, and so it can cause reflections back through the source signal. Now, certain geometries of end cuts on the fibre can help reduce that, but it's far better if it uses a more advanced technique. But we won't find out till we do it. So I should be able to dial into this things like, you know, whatever, dB. There's our steps up and down. And these are numbered as well. It might not show up very well on the camera. So I should be able to dial in, let's say that I want 6 dB of attenuation. And it should just give me 6 dB of attenuation. Or I should be able to actually do a start dB attenuation, a stop dB attenuation, and cause it to scan between those different points in various different step sizes. We can see we've got delays, and we've also got a dark setting here, which helps to calibrate things under test. So yeah, I don't have a manual for this. I did look at a manual, and it was £30 plus £70 to deliver it, so I didn't buy it. And I haven't found one online yet. If anyone does know a source, then please let me know. So there we go. This will be my next repair. So that's it for the mailbag today. Hope you enjoyed it. Take care, and I'll see you next time. Bye for now.